So now we're going to look at part B. So in part B, we got our more long answer questions. We're going to start off with this function here, f of x. And this question's slightly different than we had before, just because the order is different. So to start off, I say compute the inverse. So if we look here to compute the inverse, what we're going to do is we're going to let x equal e to the y cubed minus 2 minus 3, and we're going to solve for y. So x plus 3 equals e to the y cubed minus 2. Now we can take the ln of both sides. Ln of x plus 3 equals y cubed minus 2. Ln of x plus 3 plus 2 equals y cubed. So y equals ln of x plus 3 plus 2 all to the 1/3. And now we're looking, okay, do I have any domain constraints here? And do I have any domain constraints here? So these are the two places we're looking for domain constraints. So the domain of the original function and the range, what I'm going to do is I solve for the domain of the original function and the domain of the inverse function first, and then I use the fact that the range of the original function is the domain of the inverse, and the range of the inverse is the domain of the original. And here we're asking for set notation, and here we're asking for interval notation. So for the original function, f of x equals x cubed minus 2 minus 3, we look at it and we ask, okay, what are the domain restrictions for this function? And we're not taking the square root, we're not taking the ln, and we're not dividing by 0, so there are no domain restrictions. So our domain is the set of real numbers. And this is what we do for our set notation, which means that our range of our inverse function is going to be all real numbers, or going from minus infinity to infinity. Next, we're going to look at the domain of the inverse function. And here, I'm taking an odd root. So I'm not taking an even root. I'm just taking an odd root. So I don't have a domain restriction from the square root. I'm not dividing by 0, but I am taking the ln. So because I'm taking the ln of x plus 3 is in my function. And this tells me that x plus 3 must be strictly greater than 0, or x is strictly greater than minus 3. So this tells me that my domain is x is in minus 3 to infinity, and I'm not including minus 3. And then my range is minus infinity to infinity. And now here, I can get my range, and it's going to be the domain of the inverse function, which is the set y is the set of real numbers such that y is greater than minus 3. And here, what we could do is we could also say that y is an element of minus infinity to infinity. Okay, so now we're going to look at B3. Note that there's no B2. There's no B2 on the mock exam, and the numbering was off before I uploaded it. So I've corrected the numbering on your actual exams, but there is no question I've removed that's going to show up on the exam for section B. They're going to be similar to what you see here, as well as what you saw on your quizzes. And now when we look at this limit, first thing what we do is we do direct substitution. And if we do direct substitution property, we're going to get e to the 2 minus 2 minus 1 over ln of 2 minus 1, which equals e to the 0 minus 1 over ln of 1, which equals 1 minus 1 over 0, which equals 0 over 0. And we get this indeterminate form of 0 over 0. And when we do it, we look here, okay, is there a nice way to multiply by 1 over x or some other thing? No, there really isn't. But we have this 0 over 0. So that being a 0 over 0, oh, L'Hopital's rule. So this is going to be equal to the limit as x approaches 2 of the derivative of the top divided by the derivative of the bottom, or e to the x minus 2 times 1 minus 0 over 1 over x minus 1, which equals e to the x minus 2 times x minus 1 over 1, or sorry, it equals, and let me move this over, it equals the limit as x approaches 2 of this expression, which equals e to the 2 minus 2 times 2 minus 1. And remember here what I'm doing is I'm multiplying by the reciprocal to bring it up, which equals e to the 0 times 1, 1 times 1. So our limit is 1.